Alright, so here we're going to be talking about converting rational numbers. A rational number is really just a fraction. Anything that can be written as a ratio is a rational number. This includes fractions, decimals, and percents. Really the important thing is that all three of those are really representing the same exact thing. A fraction, a decimal, and percent is just a different way to write the exact same value. Every single number has those three forms. And really, every number has at least those three forms. We'll see that you can represent even fractions in a variety of ways, decimals in a variety of ways. Okay. So let's start with decimals, since that is the standard form of a number. That's the standard simplified version of a number, and it's the ones we start out with. Let's just look at the simplest kind of example, just a number. We're going to use 5.0. There's actually even two forms of that decimal number. We could also say it's 2 plus 3. Those are two forms of decimals that represent the exact same value. These are the exact same thing. When we talk about it as a fraction, it's a ratio comparing two numbers. Again, that's directly in the name of rational numbers. Anything that can be written as a fraction. So if we're talking about that same example, that number 5, we could write 5 compared to 1. We could also say it's 10 compared to 2. Those are the exact same value. $10 for every 2 potatoes, or $5 for every 1 potato is the exact same value. Again, percentage represents that same value, just in a different way. Now we're comparing that number. It's a ratio between the number and 100. If we're talking about 5 sets of 100 would be 500, so that's 500%. Okay. It's really the standard number times 100. The standard form times 100. Okay. All right. So these examples, we're going to be changing on the first one. We're just going from a fraction to a decimal. Okay. This is the simplest process. We just divide. And now that we have calculators, compared to last year, this is going to be a lot easier. We're just dividing. So we can do all of that in the calculator. 1 divided by 6. Make sure you don't do that the other way around. It's not 6 divided by 1. It's 1 divided by 6. That would give us that in the calculator. We don't want to write out all of that, so we're going to change that a little bit. We're going to get rid of all of those 6's and just change it to a 0.16 repeated. We could also write that a little bit differently. We could write that as 0.16666 and say that all 6's are repeating. Those are the exact same number. Either the 6's repeat individually forever, or sets of 3 repeat forever. Either way, it's 6's going on forever after that one. And the next one, we have a mixed number here. So we're going to change the fraction part into a decimal first. That's the division part. 1 divided by 2, that's 0.5. And we really just carry the 2 down. It's 2 and the 0.5, 2.5. Right, so to change a fraction into a decimal, this is one of the simple processes. We really just divide. This is just a division problem. It's saying do 1 divided by 6. Make sure you don't do 6 divided by 1. It's saying 1 divided by 6. You should end up with a decimal. This is really the decimal 0.16666 going on forever. We can write that simpler. We can write that as 1.6 repeated. Okay, the 6 is the only thing repeated. That's why it's the only thing with a line over it. So this entire idea is really just divide, do the division problem that it's asking you to do. When we have a mixed number, we're going to do that same thing. Here it's saying 1 divided by 2. That would give us 0.5. And we really just carry the whole number part of that down. So it's 2 and that 1/2, 2 and 0.5, 2.5. Letter C, we have an improper fraction. It works the exact same way. The only difference here is that we know it should be a number bigger than 1. We do 11 divided by 9. We should get some number that's bigger than 1. It's 1.222 repeated, or 1.2 with a line over it. When we have a negative sign in front, it's the exact same thing as putting the negative on top, or we can put the negative on the bottom, but we can't put it on both. A negative divided by a positive and a positive divided by a negative are both going to give us a negative answer. If we put it with both of them on the top and the bottom, that's a negative divided by negative, that would give us a positive. So we can put it with either the top or the bottom, we can't put it with both. I always like it with top. I think that looks the cleanest. We do -1 divided by 8, that's negative 0.125. Again, that's really just the operation, just do what it's telling you to do. Alright, the next one, fraction to percent, is going to involve us going to a decimal first. So we have to get to decimal form. And then we're going to change that into percent. We just did these, so we don't need to do those completely again. I'm just going to go straight to the decimal form. And remember, we do that with dividing. So 1 divided by 6 was 0.16 repeated. 1 divided by 2 was the 0.5 part of this. The 2 just carries down, so that's 2.5. This was 1.2 repeated. And this was negative 0.125. Right, so going from a fraction to a percent involves getting to the decimal first. And now we want to go from the decimal to the percent. We're going to multiply by 100. Another way to see this is moving the decimal place 2 places. Move it 2 spots. That's 16.6 repeated. When we don't have the numbers we need, we want to move this decimal place 2 places. We have 1 spot there. We don't have any number after that, so we're going to insert a 0 there and then jump over that second spot that we need. So that's 250%. Same thing here, we're jumping over 2 spots. 1, 2, it ends up in between these 2's. Really, those 2's are going to go on forever, so this is 122.2%. Same thing with the negative, it really doesn't change the process. Move 2 spots, that's negative 12.5%. We're just moving the decimal. The percent is always going to be bigger, or always going to look bigger than the decimal. It's still representing the same value. One thing that you really need to pay attention for is a different version of that number. That is the exact same thing as 66 2/3%. The decimal part of that is represented with a fraction here. Those are the exact same thing. This 0.6 repeated is the same thing as 2/3. So we can say it's 6 2/3 or 6.6 repeated. Both of those are the exact same thing. So we can represent a percent with a fraction or with a decimal. All right, when we're going from a decimal to a fraction, there's 2 ways we can think about this. The first way is really just reading the decimal place. We're going to read the place value. And what I mean by that is each decimal place has a specific name that goes along with it. The first number is the tenths place, the second number is the hundredths place. So this is 45 hundredths. The next one, the third decimal place, is the thousandths, so this is 64 thousandths. This one, we'll come back to this whole number part, but let's just talk about the 4th decimal place. We really just add a 0 every time, so after 1,000, if you add another 0, that's 10,000. So this is 12 10,000ths. It's going to be really helpful in writing the fraction because you really write exactly what you say. 45 hundredths is 45 over 100. 64 thousandths is 64 over 1,000. And 12 10,000ths is 12 over 10,000. Another way to see this, though, if you picked up on this pattern, we see that we have 2 decimal places here. We also have 2 zeros on the bottom of that fraction. We have 1 and 2 zeros. Here we have 3 decimal places. That's after the decimal point. We have 3 zeros. Here we have 4 decimal places, so we're going to have 4 zeros. All right, so there's those two ways that we can do this. We can read the place value and really just write exactly what we say. 45 hundredths is 45 out of 100. Or we can look at the number of decimal places and that equals the number of zeros. This is the first step of the problem, just writing it as a fraction. If the fraction is not simplified, we need to simplify it. We never want to leave a fraction unsimplified. Okay, so on this first one, we have 45 on top, 100 on the bottom. I see that that ends in a 5, that ends in a 0. I know those are both divisible by 5. I'm going to divide by 5 on top and divide by 5 on the bottom. That would give me 9 out of 20. 45 divided by 5 is 9. 100 divided by 5 is 20. That fraction is equal to the original fraction that we had. It's also equal to the original decimal that we had. We can confirm that just by dividing. 9 divided by 20 should give us that decimal. It's an easy way to check to make sure that you simplified correctly. I'm going to do that same thing on the next one. This one, you can try to figure out what number will divide both of those evenly, or really we see that we have two even numbers, 64 and 1000 are both even. So I'm just going to divide by 2. That's the easiest number to try to divide by 2 if they're both even. So this would leave us with 32 out of 500. Those are both still even. So I'm going to divide by 2 again. That would give us 16 out of 250. Those are both still even, so I'm going to divide by 2 one more time. That would give me 8 out of 125, and that's as far as this one goes. So you could have divided by 8 at the beginning. You could have divided 64 by 8 to get 8, and 1000 divided by 8 to get 125. Or you can just keep dividing by 2 and figuring it out that way. There's shortcuts sometimes if you recognize them. If you don't, try the easy numbers. Try dividing by 2, 3, 5, and 7. Those are the easy ones. Okay? Alright, so coming back to example 3, we have this whole number part that we need to address. We have a -1 in front of the decimal. We're going to write this out, simplify that as much as we can, and then really just add the whole number part in. It's -1 and whatever fraction we get. So let's start out with our 12 out of 10,000. We're going to divide by 2 on top and bottom. That's 6 over 5,000. Divide by 2 one more time. And that's 3 out of 2,500. So this is just the decimal part of it. We need to include the whole number part. That's -1 and 3 out of 2,500. That's our final answer. The last conversion that we need to do is a percent to a fraction. This is going to be another one of those two-steppers. We have to get to a decimal first. And then we'll turn it into a fraction. Okay? So the first part of that, going from a percent to a decimal, we just divide by 100. We move the decimal place 2 places to the left. All right, so let's just do that step on this first one. The decimal place, it really doesn't look like there's any decimal point there. If there is no decimal point, it starts at the end of the number. That's 88.0%. Moving the decimal place 2 places or dividing by 100, it ends up in front of the number, 0.88. That's 88 hundredths, or that's 2 decimal places. So that's really the number 88 out of 100. That fraction, you can just check to make sure you got that right by doing this division. You should get that as a decimal. We can simplify this. We'll divide the top and bottom by 4. That would give us 22 out of 25. I know that's my final answer because nothing else is going to divide 25 and 22. The only thing that divides 25 is 5. I know that doesn't divide 22. All right, next example. Again, first step, just change it to a decimal. Move it 2 places back, 1, 2. Again, if you don't have a number there, you have to put a 0 in there. So this is 0.0017. The next part of this is changing it from a decimal to a fraction. It's really just reading the place value. that is the 10,000ths place. So this is 17 out of 10,000. And that's my final answer. 17 is a prime number, so there's nothing that's going to divide 17. Never mind divide 17 and 10,000. 17 can't be divided by anything. All right, our next one, our final one, we're going to, again, divide by 100, move the decimal place 2 places. That's now 9.666 repeated. So that's the number as a decimal. We want to change that into a fraction. We're really just dealing with the back part of this decimal part of it. You could try putting that over a fraction, but you'd be writing for quite some time because that is going to go on forever. That's 66.666. That's going on forever. Some of these you just need to remember. 0.6 repeated is one of those that we just have to know as 2/3. So this is 9 and 2/3. Some of these are really easy to remember. Anytime it's a repeating decimal like this, 0.1 repeated, 0.2 repeated, that's just that number over 9. So 0.1 repeated would be 1/9, 0.2 repeated would be 2/9. So 0.6 repeated is 6/9. That's the exact same thing as 2/3. That's why we're getting that as the fraction part. All right, so the next thing we're going to be talking about is actually graphing these on a number line. This is the easiest way to compare an order. Which is really what we're going to be talking about more in 8th grade and 7th grade and 6th grade and 5th grade. You're really talking about just converting back and forth between these forms of a number. Now we're going to be talking about comparing each of them, which involves converting and then looking at them on a number line. Okay, so we always want to change these into decimals first. This is already a decimal. We don't have to really do anything with that. I'm just going to rewrite that as 0.300. We'll see how that helps a little bit later when we're comparing them. The next one is just a division problem. It's a fraction, 1 divided by 3. That's 0.333 repeated. 25% as a decimal. We're going to move the decimal place 2 places. It's going to move back 2. It's going to be 0.25. Actually, the same thing for this scientific notation. We're really just listening to that exponent. That's telling us to move it 2 places back to the left. We know it's going to move back to the left because that's a negative exponent. That's always going to make the number smaller. So it's going to turn into a decimal. That's 0.030. And again, for a percent, we can think of this as dividing by 100 or moving the decimal place back 2 places. And that's 0.311. Alright, so we're going to be trying to put these on the number line. I would always try to find easy benchmarks to use. 0 and 1 are always really easy to use. If we count these, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little hash marks going between 0 and 1. So that means each of these is 0.1. That's 0.1, 0.2. Let's fill these in. 3, 4, 5, 6, 7, 8, 9, and that's really 10. And so we're trying to place each of these on the number line. I would pick out the easy one first. That first one is going to be directly on 0.3. Those are equal, so our 0.3 is probably the easiest one to place. It's on one of those lines. Again, I would just keep scanning for the easy ones, the ones that you recognize. 0.25, I think, is the next easiest. That's going to be halfway in between 0.2 and 0.3. So our 25% is going to be right in between the 2 and the 3. Next, I see this one that really doesn't fit in with the other two. I see 0.030. 0.030, 0.333, and 0.311. You should see that the tens place in this one is much smaller than the other two. We have a 0 here while we have a 3 there. So we know this one is much smaller than the other two. That one's very close to 0. That's smaller than 0.1. 0.10 versus 0.03. That should be closer to 0 than 0.1. Really, it's right up next to 0. We're going to write the original form of the number, so that's 3.0 times 10 to the negative second. All right, these last two, we're trying to place 0.3 repeated and 0.311. I'm going to come back over here to compare these. we see that the 3's don't really help us. That first decimal place doesn't tell us anything. The second decimal place is what's going to be helpful. We have a 1 and a 3. We know that one has to be smaller, so it's going to be farther to the left on the number line. That one's going to be very close to 0.3. That's 31.1%. And just ahead of that is this 0.3 repeated, or the 1/3, as we're going to write it there, as the original.